Hi guys, we're starting chapter 16 today. We're actually going to do just a few random sections here as we wrap up the end of the year, all right? So, we get to start talking about the periodic table. Little history first. Dmitry Mendeleev is actually the guy that came up with the very first periodic table. He's from Russia, and this is back in like 1869. This is wow, a long time ago. Well, he noticed some patterns. He noticed some patterns in the properties of some of the elements, mainly in their reactivity. Okay, he originally put the elements that were known at that time. Not many of them were known. He originally put them in order of atomic mass, meaning how much they weigh. When we get to the actual periodic table, you'll see that mostly still follows. There's a couple of elements that are slightly out of order according to atomic mass because scientists have found a better way to organize it. But he originally went by atomic mass. Okay. He also looked at that bonding power. That's that reactivity. It was known, how many different spots were available for elements to bond with other elements. We'll talk about that later. And that was a pattern that he noticed as well. And it's kind of interesting. I like this part about Mendeleev. If you look closely, this is his actual list. You can see some question marks here, right? He knew, he had so much confidence in the patterns that he had found that he figured that there were some undiscovered elements that fit in his pattern. And so he put some question marks there saying like, okay, there's something else we haven't discovered, but according to this atomic mass, according to these properties and patterns, we're gonna eventually find it. And he was totally right. All right, atomic mass, just so you know, is the average mass of a single atom of an element. And it has to be an average for a specific reason. I'll tell you that in just a minute. Okay, let's talk about atoms. Atoms have a nucleus. That's this center part right here. That's kind of the core, and it's made up of protons and neutrons. Like 99% of the mass comes from the nucleus itself, okay? The atomic mass is measured in AMUs, or atomic mass units. It's a made-up unit because it's so small, and basically a single AMU, or one AMU, is equal to the mass of a single proton or neutron. So the protons and neutrons weigh almost the identical amount, okay? Protons are positive, that's those pluses in the middle there. Neutrons are neutral, and electrons are negative, and they're virtually weightless, okay? Now, I will tell you that since there are 1, 2, 3, 4, 5, 6 protons in this element, I can tell you that is carbon. That is a picture of carbon. And I'll tell you how I know that in just a second. The atomic number, that's how I know it. Let me move myself just a little bit lower. There we go. The atomic number is how the periodic table is organized now. If you look at any periodic table, you will notice little numbers above each of the elements, okay? That is the atomic number. And the atomic number tells you how many protons are in the nucleus, okay? So if we look at lithium, we see 1, 2, 3 protons. That means that lithium's atomic number is 3. And if you look at a periodic table, the number 3 appears right above lithium there, okay? The number of protons also equals the number of electrons. Okay, those electrons don't add to the mass at all, and they fly around the outside, but they're always an equal number. Okay, protons equal electrons. Okay, so the 3 for lithium, that means 3 protons and 3 electrons. Okay, the number of neutrons can vary though, and in that picture you see that there's actually 4 neutrons, and that's because there's different isotopes of different atoms. That's still the same element, but you can have a lithium atom with, say, 3 neutrons, say 2 neutrons, say 4. They typically show a picture of the most commonly occurring isotope. And so that's why the average atomic mass is taken. And if you look at the atomic mass of lithium, it is just about 7. It's actually 6.941 atomic mass units. Well, remember what I said, each of these protons and neutrons is one atomic mass unit, so if there's 7 there, it's just about 7 AMUs, okay? So how do we read the periodic table? Most squares are organized in a fashion very similar to this. The very top number is that atomic number. Again, that tells you how many protons there are. It's also the same number of electrons. The symbol is an abbreviation. It's 1 or 2 letters. The first letter is always capitalized. Usually it's just the first letter or the first 2 letters. Sometimes they have to skip around because there might be repeats. But sometimes you see something like this, okay? That Fe has nothing to do with iron, okay? It's not an IR or an I. It's Fe from ferrous, which is a Latin word. So sometimes we get some elements that are given an abbreviation based on their Latin word, okay? Then just the name. There's not anything else to say about the name. It's self-explanatory. And then the decimal number underneath is that atomic mass, okay? So you can see the atomic number is 26, which means there's 26 protons, okay? There's usually about twice as many, the atomic mass is usually twice that because there's roughly equal number of neutrons. As the atomic numbers get higher, though, it seems like the atoms have many more neutrons than protons, and so you'll notice that atomic mass continues to grow. It's not just double the atomic number, okay? But if we double 26, we get 52, so that tells us that there's just a couple more neutrons in an iron atom than the protons, and that's where that atomic mass comes from. The electrons don't add to that mass hardly at all, very indistinguishable, okay? Some periodic tables have some additional information, okay? These other numbers up on the top there. So back to Mendeleev, he noticed this pattern in bonding powers and the ability for elements to bond with other elements. It was known, and it's known even more now, how many bonds an element can make, okay? So if we go back to the lithium picture from earlier, oh boy, it's going to make me go through all these animations. How boring is this? Oh, there we go. Okay, so I guess that's not lithium, that's carbon. You can see that there's 6 out here, okay? But notice how they're in different circles. There's 1, 2 on the inside, and then there's 4 on the outside here, okay? There we go, there's lithium. There's 2 on the inside, and then 1 on the outside there, okay? So these electrons actually fly around in different shells. Let me get back to my page. There we go. These electrons kind of orbit the nucleus in different shells, okay? The shells have a comfortable number to them. The inside shell can only hold 2 electrons. The very next shell can hold 8, okay? And it wants to be full. And so those outer electrons are either going to share with another element, or they're going to transfer to another element, or they're going to borrow from another element. And that's how these chemical bonds are made, okay? You're going to learn much more about that when you take chemistry in high school. The valence electrons are those electrons that are in that outside shell. So when we looked at the lithium, there were 2 on the inside and 1 on the outside. That means there's 1 valence electron. And so it likes to bond with elements that have 7 valence electrons, because 1 and 7 equals 8, and then they're stable together like that. Kind of complicated, I know, kind of a brief explanation. You'll learn more about that. So here's a whole periodic table, okay? It's organized like this. Couple things to know. We've got these numbers up on the top here, and those are group or family numbers, okay? The columns of elements have similar properties, and it's because they have the same number of valence electrons. All of those elements in a family have the same number of valence electrons, so their bonding power is the same, okay? Periods go this way. They're goodness gracious. They are rows. Where's my pen? Oh well, lost my pen. They're rows. They go back and forth this way, and they don't share any similar properties, okay? But there is a pattern of reactivity. As you go from left to right on the periodic table, the reactivity tends to decrease a little bit. Because as you go, you're increasing those number of valence electrons, and the more valence electrons you have, the more stable you are, and the less necessary it is to react, okay? We may or may not get a little more detailed into the periodic table, it depends on how much time we have, but you can see that there's lots of stuff going on. There's different types of metals, there's gases, there's all kinds of funky stuff. But I do want you to recognize these two rows down here, okay? So if you notice, you go from 57 to 72 and 89 to 104. These rows actually fit right in there. But if the periodic table was drawn like that, it would be too wide, and it would shove, these things out like that, and then those group columns wouldn't line up like they're supposed to. And so this is drawn down like that, but it kind of technically tucks up in there. I know, kind of weird. I didn't design it. That is about all I have to share with you for our intro on the periodic table. Stay tuned for more information. All right, see you later.